Hello and welcome to yet another South Korean College Scholastic Ability Test video, which is a test that South Korean high school seniors take in order to go to college. Today's problem reads like this. For all natural numbers n, the polynomial fnx satisfies following properties a and b. First, f1x is given as x squared, and second, fn plus 1x is given as fnx plus the derivative fn prime x. What is the constant term of f25x? Alright, first I am going to use the good old calculate first few functions and look for patterns approach, which I'll admit does not sound very intellectual or logic based. But let's be honest, it is perhaps the very first method that comes into many people's mind and it's actually quite effective. So let's calculate the first few functions. So f1x is given as x squared, and f2x can be calculated by f1x plus derivative f1 prime x, so x squared plus 2x, and f3x is given as f2x, so x squared plus 2x plus its derivative f2 prime x, so 2x plus 2, which gives x squared plus 4x plus 2. And f4x is f3x plus its derivative, so 2x plus 4, so we have x squared plus 6x plus 6. And let's actually calculate one more just for good measure, which gives x squared plus 6x plus 6 plus the derivative 2x plus 6, so x squared plus 8x plus 12. And perhaps you have noticed some patterns at this point. As you can see, the coefficient of x squared remains as 1. The coefficient of x increases by 2 every time. And the constant term increases by 0, 2, 4, 6, and so on. This observation is more than enough to solve this problem, but since this is an educational video, let's express this more systematically. First, let's show that all f and x are quadratic polynomials with leading coefficient 1. It's obvious, but let us quickly show that in a logical manner. It's just simple induction. f1x, which is x squared, is a quadratic polynomial with leading coefficient 1. And if we assume that fnx is given as x squared plus the remaining terms rx, where the degree of rx is less than or equal to 1, then fn plus 1x, which is fnx plus fn prime x, is given as x squared plus rx plus derivative 2x plus r prime x, so x squared plus 2x plus rx plus r prime x, where the degree of 2x plus rx plus r prime x is also less than or equal to 1. This proves that all f and x are quadratic polynomials with leading coefficient 1. Next, let's take a look at the coefficients for other terms. In order to discuss those, we need to define some kind of coefficient sequence. Define ak of fn as the coefficient of x to the power of k term in polynomial fnx. Then, from the recurrence relation given in B, if we only take a look at constant terms, which can be written as a0 of a certain function, we can find that a0 of fn plus 1, the constant term of fn plus 1x, is equal to the constant term of fn plus the constant term of fn prime. And here, the constant term of the derivative comes from the x term of the original function. Therefore, a0 of fn plus 1 is equal to a0 fn plus a1, the x term of fn. So this is the constant term relation. Next, let's take a look at x terms. Then we can notice that x term of fn plus 1, so a1 fn plus 1 is equal to a1 of fn plus a1 of fn prime. Here, the x term of fn prime is equal to twice the coefficient of x squared term of fn. So we have this and plus 2 a2 of fn. And since the coefficient of x squared is always 1 for all fn x, we have a1 fn plus 1 equals a1 fn plus 2. This second relation is a recurrence relation of the arithmetic progression, which we can find its general term quite easily. Using the first term a1 f1, the x term of f1x, which is 0, and the common difference 2, the general x term, which is a1 of fn, is first term 0 plus common difference 2 times n minus 1, which is 2n minus 2. Substituting this into recurrence relation 1 gives a0 fn plus 1 equals a0 of fn plus 2n minus 2. So this time we are given the difference sequence a0 of fn plus 1 minus a0 of fn equals 2n minus 2. And we can use this difference sequence to find the general term. The general term a0 of fn is given as the first term a0 of f1 plus the sum of difference sequence a0 fk plus 1 minus a0 fk, where k goes from 1 to n minus 1. So the constant term of f1 is just 0, so sigma from 1 to n minus 1, the difference sequence 2k minus 2. So we have 2 times sigma k minus sigma 2. So we have 2 times the sum of natural numbers up to n minus 1, which is n minus 1 divided by 2, minus the second term simply gives 2 times n minus 1. This gives n squared minus 3n plus 2, which is actually factorable, into n minus 1, n minus 2. So this is the constant term of fn. Here we want to find the constant term of f25x, which is a0 of f25, which is equal to 24 times 23, which is 552. Therefore, the correct choice is choice 3. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.